day, viewers. Welcome to today's mathematics class. By the grace of God, today we shall be looking at the topic set theory. Now, in our daily life, we often come across phrases set. We have sets of domestic animals, sets of even numbers, set of odd numbers, set of cutlery, and so on. So I believe set is not a new thing, or it's not a new word to us. So let's look at, there are some sets that have special names, like football team. They are also set of football players or members. Then we also have bunch of bananas, also set, and so on. So let's look at the definition of set. A set can be defined as a group or collection of well-defined objects or numbers. So I've already given us example of the set. Set of numbers, set of even numbers, set of vowels, sound, and so on. A set is usually denoted by a capital letter. So when you want to write a particular set, we use capital letter to denote the set. Set A, set B, set C, and so on. Then we have the elements of a set. That is member of a set. Remember I told you consonants. So consonant, if I should list out the consonants in a set, that consonant now, they are the elements of that set. So the elements of a set are the objects or numbers that belong to a set. The objects or numbers that belong to a set. So for example, if I say set A is set of even numbers. So even numbers like 2, 4, 6, now we call them the elements of the set A. Now, elements of a set are also called members of a set. So if I did not say element of a set, I can also use member of that set. So for example, we are using Z as an example. Z is equals to, we have some dotted line, then -3, -2, which means we have other numbers. Then -3 and so on, and others. So this one is an infinite set because we have plenty numbers, uncountable numbers. The elements are separated by commas. Based on the example we have on the board, you discover that the elements of the set are separated by commas and are written in a pair of curly brackets. The brackets, not anyhow brackets that you write a set, not anyhow bracket. So it must be a curly bracket. Let's look at sets, describing a set. Set can be described in 3 ways. We can describe set in 3 ways. So the first one there, a set can be described by listing all its elements or members written in the bracket. So if all the elements are written in the bracket, then that is one way you can describe a set. For example, set P is equals to 2, 3, 5. That is the only element in set P. They are all complete. So you can describe it like that. Like V is equals to A, E, I, O, U. That is all the elements in set V, and so on. When all the elements of a set are listed, it is called the tabular form of a set. You can also call it tabular form of a set when all the elements are listed. Then we also have the second one. A set may be described in words. So we may not write it as 1, 2, 3. It may be written in words. Example, M is equals to multiples of 3 from 3 to 18. Another example, set C is equals to consonants. Set D, domestic animals. So we can describe a set in that form. I can also say, okay, set N, set of even numbers. You can limit it. So if you leave it open, as I told you earlier, that is an infinite or infinite set. Then the third way, a set may be described algebraically. We can write it in an algebraic form. Example, set A is equals to x such that the x ranges from -5 to 3, where x is an integer. So they must explain this x. Okay, or we say where, if this y, we say where y is an odd number. So this x must be explained, or they will say multiple of a particular number. Okay? So that is it about the description of a set in 3 forms. Alright, let's look at types of set. We have so many that you can even add more to what I have on the board. We have universal set, we have the subset, the finite set, the infinite set, the empty set, or we call it the null set. We have the equivalent set, equal set, unit set, or singleton set. We have the disjoint set and the power set, and so on. You can list them the way you want. Now, let me just give 1 or 2 explanations on each of this one before we proceed. The universal set. The universal set is normally the set under consideration. That is, all other subsets or all other sets that you will discuss under that set the element should be in the universal set. So we say that the universal set is the set under consideration. So everything that you will discuss in that question or problem should be from the universal set. Then we have subset. I can say that set A is a subset of set B if all the elements of set A belong to set B. We will take them one after the other and look at it in detail. Then we have the finite set, or we say the finite set. This finite set, that is, they are the sets that all the elements in the set are listed. Remember, I've explained elements already. That is, all the members of the set are listed. Then the infinite set are the sets that all the elements are not listed. We have uncountable elements of set in that set. You cannot list all the elements in that particular set. Now, when you talk about the empty set or the null set, it's a type of set that is what? Is empty. It has no element in it. I will tell you later most of these things. So it has no element. So if a set has no element in it, we call it an empty set, or we call it a null set. Then we have equivalent set. So when we talk about equivalent sets, it's comparing 2 things. So 2 sets are said to be equivalent if they have the same number of elements. They have the same number of elements. For example, set A and B. So if the number of elements in set A are 3 and the number of elements in set B are also 3, we say that they are equivalent. Then we have equal set. When we talk about equal set, 2 sets are said to be equal if they have exactly the same elements. So take note the difference between the equivalent and the equal. So in the equal set, the elements are equal. If set A, the elements in set A are 1, 2, 3, then the element in set B should be also 1, 2, 3. So that is what we mean by equal set. Then we have the unit set or singleton set. So a set is said to be a singleton set if it has only 1 element in it. So you have only 1 element, we say it's a singleton set. Then we have a disjoint set. 2 elements are said to be disjoint if they have nothing in common. They don't have anything in common. Set A don't have anything in common with set B. Then we say that they are what? Disjoint. Then we have the power set. When we talk about the power set, we are talking about the number of subsets. Number of subsets in that particular set. We shall look at them one after the other. So let's start by looking at the subset, even though I've given a brief explanation about the subset, but then let's look at it in a more detailed form. Set F, I'm using F as an example. Set F is a subset of G if and only if every member or element of F is a member of G. So let's take for example, set F. The elements in set F, or the members of set F, are 2, 6, 10, 12, and 14. And the members of set G are 2, 4, 6, 8, 10, 12, 14, 16. So from what we have from set F and G, you notice that all the elements of F are in G. Therefore, we say that F is a subset of G. And it can be written as F is a subset of, please, it's not C. F is a subset of G. Or G is a superset of F. That is if you take it the other way round. So that is the subset we are talking about. Now let's look at the universal set. We have a symbol for universal set. So if you see this symbol, it's a symbol for universal set. Or you see a capital letter U, it's also a symbol of universal set. So universal set, as I said, is a set that contains all the members of the other set under consideration. So all the members of other sets, you may have 2 or 3 sets under the subset. So all the members in it must be in the universal set. So an example, for example, we have U is equals, that is the universal set, is equals to 1 to 10. That is the universal set. Then we have the subset. A is 1, 3, 5, 7. Then set B is 2, 3, 4, 5, 6, and 8. Then A and B are subsets of the universal set. So anything you want to discuss, if you have a problem, you want to discuss it, then everything must come from the universal set. You may find the union of the sets, the complement, the whatever, all of them, it should be from the universal set. Then we have complements of sets. The complement of set F, I'm still using F as an example. The complement of set F is the set of all members in the universal set which are not in F. So remember I told you the universal set, we always go back because it's the set under consideration. So if you want to get the complement of set F, then they are that element that they are not in F, but they can be seen in the universal set. So let me take an example with set A here that we have. Okay, now this is our universal set. Let's look at set A. So if you want to get the complement of this set A, they are those elements that are not in A, but they are in the universal set. So can we look at, let's bring out those numbers that are not in A, but they are in the universal set. We have 2, we have 4, we have 6, we have 8, and we have 9 and 10. So those numbers 2, 4, 6, 8, 9, and 10 are the complements of set A. And we have we have a symbol for that, which is F prime. Or they can write it FC. That is raised to power C. So that is the symbol. So if you see A prime, it means A complement. If you see F prime, it means F complement. We have union of sets. Union of sets. The union of set A and B, I'm using A and B as example here now. The union of set A and B, denoted by A union B, we use U for union. So A union B is the set of all elements belonging to A and B. When we talk about union now, union, coming together, you unite, we bring all the elements in set A and all the elements in set B together, but without repetition. If you have repeated numbers, then you only pick one. Okay? That is union of a set. So for example, let's go back to the universal set. In our universal set, I'm taking an example of A and B from the set that we have here. So what is A union B? That is all the elements in set A and all the elements in set B, but without repetition. So what will be the union of A and B now? It will be 1, 2, 3, 4, 5, 6, 7, 8. That is the union of set A and B. You can see we have 3 here, 3 here, 5, 5, but will not double it. So that is union of a set. Now let's look at intersection. Intersection of set. The intersection of set A and B, denoted by N, A intersection B, is the set of elements that are common to both sets. So the elements that are common in set A and the elements that are common in set B, we say that that is the intersection. So let's go back to this universal set again, because I used A and B as the example. We have set A here and set B. So what are the elements that are common to A and B? So from what we have on the board here, we have 3 is 1. We also have 5 is 1. So 5, 3 and 5 are the intersection of what? A and B. So A and B, that is 3. A intersection B is what? 3 and 5. So let's look at empty set. Remember I told you, when a set has no element in it, we say it is an empty set. That is what we have. An empty set is also called a null set. Is denoted by empty. You can open and close the curly bracket. Remember I said we don't use anyhow bracket for set. So if it is not a curly bracket, then it is not a set. If it is not a curly bracket, then it is not a set. So we use curly bracket. You can open and close the curly bracket. You can see it's empty. We call it empty set. Or we use this sign for it. So once you are using this sign, don't put it in a curly bracket. Because when you put it in a curly bracket, it means it has an element. And what is the element? Empty. So you leave it like this. Or you open and close the bracket empty without anything in it. So that is an empty set. Then we have a disjoint set. If set F and G have no common element, then F and G are disjoint. So if you have two sets that they don't have anything in common, remember I talked about A intersection B. So if A intersection B don't have anything in common, it means they are disjoint. So F intersection G is equals to empty. Or you write it like this. It means they are what? Disjoint. They don't have anything in common. Then we have the power set. We have the power set. The power set of a set is a list of all its possible subsets. List of all its possible subsets. Because in a particular set, you can get other sets in a subset. So list of all its subset is what we call the power set. So if R is this, I'm taking an example using R as a set. Set R is 1, 2, 3. The power set of R is, we can write it as 2 raised to power number of elements in R. Number of elements in R. So the power set of R, you now list them one after the other. One itself, that is each element is a subset of its own. Each element is a subset. Then you can now join them. You begin to join them. Like what we have here, one can stand on its own as a subset. Remember we talked about singleton set. 2 can also stand on its own. 3 can also stand on its own, and they are all subset. Then I can now bring 1 and 2. They are also subset. 1 and 3, it is a subset. 2 and 3, it is a subset. And the set itself is the subset of itself. Meanwhile, remember, empty set is a subset of every set. So when you count them all like that, you discover that you have many subsets in a given set. So that is the power set. So if you finish this one, for example, this one that I used, I omitted the in 3. So if without 3, we have 1 as a subset, 2 as a subset, then 1, 2 as a subset. Then we have the empty set as a subset. Empty set is a subset of every set, and the set itself is a subset of itself. So that is all about the power set. And I say you can write it as 2 raised to power the number of elements in set R. So if they ask you to give the number of subsets in a particular set, this is the formula that we use. So now that we have 3 elements here, I want to get the power set here, or the number of subsets in this particular set. I will now write 2 raised to power 3, because I have 3 elements here, 1, 2, 3. So 2 raised to power 3, which is 8. So in this one, I should have 8 subsets in this particular set. So if I'm using only these 2, I'm using 2 sets, 2 elements, then I'll have 2 raised to power 2. So the number of subsets in that set will be 4. Let's count it here. 1, 2, 3, 4. So if you do this one too, you're going to get 8, and so on. If you have 4 elements, so it will be 2 raised to power 4. So when you begin to bring out the subset, you discover that that is what you will get from here. So I think with this one, we have explained most of the things. So in our next class, we will just look at the calculation, how to find the intersection, to find the union, and other things, complement of a set, and so on. Thank you. Have a nice day.